Today we're going to cover integrating by substitution, and what we're going to be dealing with is the situations we have not been able to handle yet. For example, if I wanted to integrate the square root of 5x plus 7 dx, there are a lot of situations that we just have not seen yet. And this is one of those. And so let me just kind of start talking about how we integrate using the substitution method. So what we're going to try to do is we are going to try to make replacements. Okay, or substitutions, whichever way, whichever word you understand better. We're going to make replacements that we can integrate. So, on this problem, if I let u equal the mess, which in this case is 5x plus 7, I'm going to call this the mess. And most of the time, that's going to be your procedures. You're going to let u equal the mess. Now, if u is equal to 5x plus 7, what would the derivative of 5x plus 7 be? Of course, that would be 5. Now, we give that a name. We give that derivative of 5x plus 7 a name, and we call it du instead of dx. We're going to call it du. And when we do that derivative of 5x plus 7, we go ahead and add on the dx. Now let me show you what we've done here. I have now accounted for everything that is in my original expression. I have a 5x plus 7. Here's a 5x plus 7. And I have a dx, and I have a dx. The one thing that was not there before was this 5. And so what we need to do is introduce something to cancel that out. I'm going to introduce 1/5 in front of the expression. Why? Well, because 1/5 times 5 is 1. And so in essence, that kind of negates this 5 that's here. So what do I have now? Well, let's rewrite this integral. Now I have the integral of the square root of u du. But I told you that we needed to introduce a 1/5. Now, why did we go through all of that? Because I can integrate this. I couldn't integrate this in the way it was. So once you get it into this form right here, well, it's normal. I can call this the integral 1/5 times the integral of u to the 1/2 du. And now we can just use my power rule with this u to the 1/2. I add 1 to the 1/2, and it becomes u to the 3/2 over 3/2. I still need to multiply it by the 1/5, and then that's going to be plus c. Okay? Let's clean that up a little bit. I'm out of room on this page. Now I have 1/5 times u to the 3/2. Now if I divide by 3/2, it's the same thing as multiplying it by 2/3. All right, plus c. And this problem is done. The only thing I need to do is I need to put the expression back in for u. So my u was 5x plus 7. So my final answer when I put in the 5x plus 7 is 1/5 times 5x plus 7 to the 3/2 power times 2/3 plus c. Now of course I can multiply these two together and I would have 2/15 times 5x plus 7 to the 3/2 power plus c. So to review, all we're trying to do is rewrite this thing by making a substitution for the mess, okay, then take the derivative of that mess to account for my dx. All right? Let's do another problem so that you can start getting the hang of this. Let's say that I was integrating, this one's much easier, I think, the integral of cosine, excuse me, of 4x dx. Well, in this case, the mess is just this little 4x. So I'm going to let u equal 4x. Okay? So, like I told you, the next thing we do is find the derivative of u, which we said we're going to call du. So the derivative of 4x is 4, and then remember what I told you, we write dx after it. All right? And now we have accounted for everything up here. We've got a dx accounted for, we've got a 4x accounted for, and I just need, but I don't have this 4 accounted for, so I need to introduce a 1/4. All right? There was no 4. Please note, on this 4 thing, there was not a 4 written in the original problem like that. So that's why we have to introduce the 1/4. So what do I have now? I put my 1/4 out in front. I have 1/4 times the integral of the cosine of u du. Okay? So I've rewritten it with my substitutions, all right? And now I can just integrate this thing. And boy, that's easy to integrate. The antiderivative of the cosine of u is the sine of u. And then I have 1/4 times that. Of course, it's going to be plus c. And the only thing I need to do is put my u back in. So my final answer is 1/4 times the sine of my u was 4x. So it's the sine of 4x plus c. Okay? And that is how integration by substitution works. I'm going to try to give you some more examples here so you can get a feel for it. Let's say that I had the integral of 2x cubed plus 1 to the 7th times x squared dx. Now remember what we're trying to do. We're trying to represent everything that's up there. All right? So I told you to let u be the mess. Well, this looks like the biggest mess I've got. Let u equal 2x cubed plus 1. And then I told you to take the derivative of that mess and call it du. So the derivative of that is 6x squared, and then we say dx. Well, look what I have. I've accounted for the 2x cubed plus 1 right here. I've accounted for the x squared right here. So now I just need to, because of this 6, I just need to introduce a 1/6. Okay? So now my integral looks like this. It is 1/6 times the integral of, I said this thing right here is u, so it's going to be u to the 7th. U to the 7th du. Because the du accounts for the x squared dx. All right? And now, boy, using the power rule, this problem isn't bad. This is going to be equal to 1/6 times u to the 8th over 8 plus c. And I can just put, do my fraction work. That's going to be 1/48. And then put my u back in. My u was 2x cubed plus 1, so it's going to be 2x cubed plus 1, that whole quantity to the 8th power plus c. Okay? Now, these can look all kinds of different ways, so I'm just trying to give you a number of examples, like some of the situations that you might see. What if I had the integral of x squared minus 1 over x cubed minus 3x plus 1 to the 6th dx? I'm going to pause the video and let you see if you can figure out what substitution to make. All right, the substitution I would make is to let u equal this mess, x cubed minus 3x plus 1. Now let me show you why I would do that. When I take the derivative of that, du is 3x squared minus 3. Now you might be saying, well, how does that help me? Well, and then of course I need my dx. Well, that's what this is. 3x squared minus 3 is just that. It's just been multiplied by 3. This is the same thing as 3 times x squared minus 1. All right, dx. So I've accounted for everything. I've accounted for the denominator right here. I've accounted for the numerator right here. I just have this new little 3 I didn't have, so I need to introduce a 1/3. So now my integral is, sorry about that, I need a 1/3 out in front of it, and I'm going to have 1 over u to the 6th du. All right? Because the du, okay, accounted for all of this. Okay? So now, this is the same thing as 1/3 times the integral of u to the negative 6th du. And I just follow the power rule, add 1, so that's going to be 1/3 times u to the negative 5th over negative 5. And that's going to be negative 1/15, all right, times 1 over my u to the 5th power. Well, my u was x cubed minus 3x plus 1, all to the 5th power, and then I would need a plus c. Okay? Now, sometimes you need to know that you may have to use an identity. What do I mean by an identity? You may have to use a trig identity before starting or during the process. Okay, we learned all those trig identities for a reason, and so sometimes you may have to use a trig identity in the middle of the process. Let me give you an example. What if I wanted to find the integral of the cotangent of 7x? Well, if you look at your integral table, there is no integral, that we've learned anyway, for cotangent. Okay? So what we're going to do is I'm going to rewrite this thing. Remember what cotangent is. It's the integral of the cosine of 7x over the sine of 7x dx. Okay? So if I let u equal the sine of 7x, then du is the cosine of 7x, we have to do the chain rule, times 1/7. All right? So look what I've done. I've accounted for everything. There's a sine of 7x. There's a cosine of 7x all over here. I wound up with this 1/7 I didn't have, so I need to introduce the reciprocal of that. I need to introduce a 7. So look what I've got now. I have 7 times the integral of 1 over u du. Remember, the du is accounting for all of this. Okay, I didn't write my dx over here. Now, like I pointed out to you the other day, if you think backwards with an antiderivative, all right, The derivative of natural log is 1 over u, so if I'm doing the antiderivative of 1 over u, it is the natural log of u, okay? And of course that needs to be positive, so we put, excuse me, we put an absolute value around it. It's still times 7, okay, plus c. And then you can just put your u back in, all right? So your u is going to be the sine of 7x plus c. I just realized something with my derivative over here. You probably caught it. The derivative of the sine of 7x is the cosine of 7x times 7. Sorry about that. You were probably confused there for a second. That's times 7. So I should have introduced a 1/7, okay? 1/7. Sorry about that confusion. But anyway, not a difficult problem after I make this trigonometric substitution. Let me do one more. Let's say that I had the integral of dx over cosine squared 2x. Okay, now the first thing you notice is the way this thing is written. They put this dx up here. And that'll happen sometimes. Don't let that upset you. Just rewrite it the way we're used to, which is 1 over cosine squared 2x, and then the dx is over here. Okay? That's the way we're used to seeing it. And if you think about it, it does make sense. Dx times 1 is dx, and that's how they came up with it. All right? Now, if I try to do a substitution here, it's not going to help me because I have this cosine squared thing. All right? So there is another way I can write this, though. 1 over cosine is secant. So I can write this as the integral of secant squared 2x dx. Now, what I want you to see is that if I let u equal 2x, then du is 2 dx, all right, which means I would need to introduce a 1/2. I now have that this thing is equal to 1/2 the integral of secant squared u du. And if we think backwards with our antiderivatives, the derivative of tangent is secant squared. So this antiderivative is the tangent of u times 1/2, and of course it's plus c. Then all you have to do is put your 2x back in for u, and I have 1/2 the tangent of 2x plus c. So, and there are some other trig identities. I said this would be the last one, but let me do one more. Just trying to help you as much as I can with these trig identities. What if I had the integral of cosine cubed x dx? Okay, this one's a little bit strange because we don't know any identities for cosine cubed. But if I rewrite this as the integral of cosine times cosine squared, okay, and of course these both have an x in them, dx. Now there is something that I have an identity for, okay? Remember cosine squared. Remember this identity? Sine squared plus cosine squared equals 1. Well, that means that cosine squared equals 1 minus sine squared. So I can replace cosine squared with 1 minus sine squared. Let's do that. I now have the integral of cosine x times 1 minus sine squared x dx. Okay? And the reason why that is important is if I let u equal the sine of x, then du helps me cover everything else. The derivative of sine is cosine of x dx. And now I can rewrite, so this du is going to take care of this cosine x and this dx. This u is going to take care of this. So look what I've got. I now have just the integral of 1 minus u squared du. Much easier. And now I can integrate that with an antiderivative. And so that would be u minus u cubed over 3. And of course it's going to be plus c. And then you just put your u back in, and this is going to be the sine of x minus sine cubed x over 3 plus c. And we will stop there for today.